Hello. This video will talk about representation theory. I'll also announce what my class is on. So, a representation is, well, a representation or P is a homomorphism of a group G to okay, so to GR. Let's just say complex. So this is the set of invariant matrices with complex entries for a group under multiplication. So for instance, if the group is S3, symmetric group on 3 vertices, then the trivial representation is like for all G and G, B of G goes to the identity matrix. So let's say this is like n equals 2. So like the elements of G, they're like the identity, reflection over a height, reflection over another height, reflection over another height, a rotation by 120 degrees, and a rotation by 240 degrees. So here phi sends everything to the identity matrix. The alternating representation it sends everything to the sign of it. So yeah, so you can check that this satisfies like phi of G H is phi of G E of H. So that's what it means to be a homomorphism. So yeah, let's check so the alternating representation, right? So if you do nothing to the vertices, it sends it to the identity. If you rotate the triangle 120 degrees, it also is sent to the identity because it's an even permutation. If you rotate it to 40 degrees, it also sends it to the identity because it's also an even permutation. Like this permutation on the, if it acts on the vertices as a group action, then maybe this is like 1, 2, 3, and 3, 2, 1. So these are even permutations. The reflections over, maybe this is like 1, 3. And this is another reflection, maybe 2, 3. And this is another reflection, maybe 1, 2. This sends, these get sent to the negative eye. So you can, so you can check that this is also a homomorphism. That's what I said. So for any G, H, and G, V of GH is V of G, V of H. So we can also send everything to a distinct element. So, maybe like the identity. We get sent to the identity. The rotation by 120 degrees. It gets sent to the rotation matrix. Maybe we will use, so we can use pi. So cosine, where pi is. So, and then, so let's see, let's label the vertices like 1, 2, 3. So this is R1. Then this like 1 and 2 swap. So let's see, what would this be? So if this is centered at the origin, like y gets sent to -1. So like the x changes signs and the y stays the same. This is R1. And then like any other matrix is any other group element is a product of these to some two of these. Like we can generate the whole group with just R120 and R1. Yeah, so this would like, be the reflection over like y equals -1/√3x. This would be the reflection over y equals x/√3. So you can check that this is also a group homomorphism. It is a homomorphism, and the map is a homomorphism. So yeah, representation theory, let's convert like view elements of a group as like elements in a matrix group. So like if you view a group element as a matrix, then you can apply linear algebra to it. So for instance, I think, under some conditions, every representation is a direct sum of irreducible representations. So every representation can be like written as a direct sum of like these blocks. So like in linear algebra, this means that it's a direct sum. So I Like they're sort of, or I don't know. So like in matrices, you can write it kind of in block form. So if you have the group Sn or S3, maybe it's a direct sum of the trivial representation and the alternating representation and something else. Okay. I'm also going to be teaching a couple classes this fall. So our math counts class, we're running like Sunday mornings, like 8:30 to 10 a.m. Central Time. And then, so we're going over past math counts tests, like math counts state and chapter, state and nationals tests, mostly sprint round, but also a couple of team and uh, target rounds. Our AMC 12 class is going to be starting September 5th. So this is Saturdays, 2:30 to 4 p.m. Central Time. So we're going to be looking at past AMC 12 problems and yeah, and possibly like some Mandelbrot and Arnold problems as well, and purple comment. But mostly the focus is on AMC 12. So for instance, we'll go over complex numbers, trig and the relationship, conics, logs, uh, geometry, counting, algebra, some basic number theory, and something else. So probably 1 week of 2D geometry and 1 week of 3D geometry. So yeah, if you're interested in either of those classes, you can email me here. And I always meet with new students first before you join. So yeah, if you're interested, feel free. If you're not, feel free to ignore this part. But yeah, math competitions are a good way to get started learning math. You can branch into programming competitions, higher level math, um, programming and software engineering in general, trading and finance, and just general anything that involves something technical or problem solving. And, you can kind of like go from math contests to doing that. So it's a good, yeah. Now, if you like this video, let me know. Feel free, please comment. Um, I'll try to post more videos on abstract math if you guys are interested in the future.